Let's see the logical operators, which is third one. So these operators are used to evaluate one or more relational expressions. And then logical operators always returns either 0 or 1. So the same like the relational operators, it only returns either 0 or 1. So we have the sum of the operators here and their meaning. So this is two ampersand symbols, which is mean for the logical and two modulus symbols, which is mean for the logical or, and exclamatory mark, which is for the logical not, and this exponential one, which is mean for the logical XOR. We can also call it as the logical exclusive OR. So these are the four operators which we use in the logical operators, and we shall discuss all these operators one by one along with the example. So the logical and, so we have seen the definition. These operators are used to evaluate one or more relational expressions. So here we have the expressions. So let's understand the logical and expression 1 and expression 2. So we have the two expressions. First expression is, if first expression is 0 and the second expression is also 0, then when we use the logical and, so expression 1 and expression 2, so we are using the logical and in between these two expressions. If the first expression or the statement is 0 and second statement is also 0, then when we apply logical and, we also get it as the 0. And 0 1 is 0 and 1 0 is 0 and 1 1 is 1. So it is just like if the statement is true or the false. If the first statement is false and the second statement is also false, then the final answer will be false. And first statement is false, second statement is true, then also the final statement will be false. And if first statement is true and second statement is false, final statement will also be false. And if both the statements are true, then final statement will also be true. So this is about the logical and. So logical and operator returns 1 if given all expressions are true, returns 1, otherwise it returns a 0. So in this logical and, if we can say it as, in logical and, if all the expressions or the statements are true, then it returns true, it returns 1. If all the statements, then it returns a false. Only it have the one case which it returns the 1. So this is the logical and. Let's see the example on this. Here is the example for the logical and. The n is equal to 9 greater than 4 and logical and 14 less than 15, and ended with the semicolon. So here in this statement, this also we can also write it in the program. And the first statement, 9 is greater than 4. Yes, the statement is true, so it returns 1. Next, 14 less than 15. 14 is less than 15, this statement is also true, so it returns 1. So 1, logical and 1. So when both the statements return 1, then the final will also, it returns the 1. So n equal to 1. So here we are using the relational operator. This is a relational operator and this is also a relational. Both are the relational expressions, and we are performing the logical operator in between the relational expressions. So this is nothing but the logical operator. And the second example is 14 not equals to 17. Yes, this statement is true, so it returns 1. Next, we are performing the logical and between with the 9 greater than 24. So 9 is greater than 24, the statement is false, so it returns 0. And in between these two, we are performing the logical and. So if one in the statement, if one statement returns 0, then finally also it returns 0 only. So in the previous we have seen 1 0 is 0. So finally a is equals to 0. Then next, the third example on this logical and. So x is equal to 4 less than 1 and logical and with 9 greater than 7, logical and 10 is equal to 14. Now 4 less than 1 is false, so it returns 0. 9 greater than 7, the statement is true, so it returns 1. Next, 10 is equal to 14, the statement is false, so it returns 0. So first 0 1, when we are applying the logical and in between these two, so 0 1 is 0. Now we had to take the 0 here, and in between these two we had to apply the logical AND, because the operator here is logical AND. Now 0 0 is 0, so finally x is equals to 0. So this is a way of applying the logical operators. So it provides the relation between the relational expressions. So to evaluate one or more relational expressions, we use the logical operators. So this is about the logical AND. Now let's see the logical OR. This is represented by the two mod symbols. So in this also we will have the expression 1, expression 2 and expression 1 logical OR expression 2. So in this, if 0 0, if the first statement is 0 and the second statement 0, then it logical OR between these two expressions is also 0. So 0 1, then 1, 1 0 1 and 1 1 1. So whenever the in a statements, if there are two expressions, if any of the expression returns 1, then the logical OR also returns 1. So just you have to remember all this. When both statements are false, then the final is also, it returns the 0. Now let's see the example for the logical OR. So the example here, n is equal to 29 greater than 14 and logical OR 14 less than 15 and ended with semicolon. So in this, there are two relational operators, relational expressions. So 29 is greater than 14, the statement is true, so it returns 1, and 14 less than 15, the statement is also true, so it returns 1. Now in between these two we are applying the logical OR. So 1 or 1, so finally it returns the value as 1, so n equal to 1. And the second example, n equals to 10 is equal to 9 logical OR 14 not equal to 14 ended with semicolon. So 10 is equal to 9, so this statement is false, so it returns 0. And logical OR with the expression 14 not equals to 14, 14 is equal to 14, but they are saying that it is not equal, so this statement is false, so it returns 0. Now in between these two statements we are applying the logical OR. So 0 logical OR 0, so finally it gives the value of n as 0. So this is about the logical OR. Now let's see the logical XOR. Here also we will have the two expressions, expression 1 and expression 2. So logical 1 XOR logical expression 1 XOR expression 2. Now in this, if both statements are false, then it returns false. If first statement is false, second statement true, then also it returns 1. If first statement is true, second statement is false, then it returns 1. And if both statements returns true, then it returns 0. So logical XOR returns 0 if all the expressions returns the same result, it returns 0. So here if these both expressions are returning the same value, so finally it returns the 0, and the same with the 1, then it returns 0, either 0 or 1, otherwise it returns the 1. Now let's see the example for this XOR. So n equals to 29 greater than 14 and XOR logical XOR 14 less than 15. So 29 greater than 14 is true, so it returns 1. 14 less than 15 is true, then it returns 1. Now in between these two we are applying the logical XOR. So when both the statements returns true, then finally logical XOR returns 0. So here 1 logical XOR 1, so it returns 0, n equal to 0. Next, x is equals to 9 greater than 14 and a logical XOR 14 less than 15. So 9 greater than 14, this statement is false, and logical XOR 14 less than 15 is true. So we are between the applying the logical XOR between 0 and 1. So first statement is 0, second statement is false, then finally it returns 1. So therefore this is x. So when we are applying logical XOR between 0 and 1, so it returns 1. Therefore x is equals to 1. So this is about the logical XOR. Then finally we have the logical NOT. So this is represented by the exclamatory mark. So in this we will have only the one expression. If the expression is false, then it returns 1. If the expression is true, then it returns 0. So this logical NOT returns 0 if the expression returns 1. So it returns 0 if the expression is 1, and this logical NOT returns 1 if the expression returns 0. So this is completely opposite to the given expression. Now let's see the example of this logical NOT. So NA is equal to logical NOT of 4 greater than 6. So 4 greater than 6 is, this statement is false. So it returns 0. And when we apply logical NOT to 0, so expression, if the expression is false, then it returns 1. So here if you see, if the expression is false, it returns 0, then the given expression returns 1. So here 4 greater than 6 is false, then logical NOT of 0 is 1. So n is equal to 1, and n is equal to logical NOT of 9 greater than 7. So 9 greater than 7, the statement is true. So when we apply the logical NOT, it returns 0. The statement logical NOT returns 1 if the given expression is 0. So these are the two examples for the two statements. And the next, write a C program to implement all logical operators. So in logical operators, we have seen the 4 types: logical AND, logical NOR, logical OR, logical XOR, and logical NOT. Now we have to write a C program to implement all these logical operators. So first, we have to include the header files, hash include stdio.h and hash include conio.h, and it starts with the main function. Open the block, and int we have to declare the 4 variables. So int and, int or next or, not, and XOR. So these are the 4 variables I am declaring to store the final value, and ended with the semicolon. So after declaring variables, then clear screen. The output of the previous programs has to be cleared. And then next, now for each of the variables I am giving some of the expression here. So first one, AND is equal to 4 greater than 5, and logical AND 2 not equals to 3, and OR equals to 12 is equal to 14, and logical OR 20 is less than 45, ended with semicolon. Next, not equals to logical NOT of 29 greater than 78, ended with semicolon. Next, XOR is equal to 34 is less than 89, and greater this logical XOR and of 4 greater than 9, and ended with semicolon. So I am applying all these operators, logical operators, in between the relational expressions. Now after declaring all these variables, now I have to print the statements here. So the print statement, so printf logical AND is %d \n, and this %d is for AND. So after performing these expression, after evaluating these, the final value either 0 or 1, that will be stored in the AND. Now when I print here, when I take the % AND, that will be printed along with this print statement. So logical AND is it depends based on the AND value we get. Now the statement, the same printf for the logical OR, and then logical NOT and logical XOR. So for logical OR, it should we have to take the %d for the OR, because on OR only we are performing the logical OR operator. Now after all these 4 statements, we have to get CS, then after return 0, close the block here. So first one, when we see the AND 4 greater than 5, so I am just writing here. So 4 greater than 5, the statement is false, and logical AND 2 not equals to 3, the statement is false. 2 is not equals to 3, the statement is false. So when we are applying the logical and between 0 and 1, so it returns 0. Then the next one we have the 12 is equal to 14. The statement is false, and logical or 20 is less than 45. The statement is true. So 1. So the first one, 12 is equal to 14, the statement is false because 12 is not equal to 14, and 14 logical or 1. So finally, when we are applying the logical or between 0 and 1, it returns 1. The next one, logical not of 29 greater than 78. 29 is not greater than 78. So the statement is false. So we get 0. And when we are applying the logical not to the 0, then it returns the 1. Then next one, 34 less than 89. So 34 less than 89, the statement is true. So that is 1. And logical XOR of 4 greater than 9. The value, it returns 0. The expression is false, so it returns 0. Now 1 logical XOR is equal to 1. So this is, so it now this 0 value will be stored in AND, 1 will be stored in OR, 1 will be stored in NOT, and 1 will be stored in XOR. So after storing all this, after evaluating all these statements, then when we print, that value we will get after this statement. Now we get the output as logical AND is 0 and logical OR is 1 and logical NOT is 1, then logical XOR is 1. So all these statements will be printed and the final value will be stored in the given variables. So this is about the logical operators, and this is also the important for the exam.